Hello, I welcome you all. The problems both come from the engineering mechanics dynamics 14th edition by RC Hibbeler. In this video, we are going to solve the first problem, and the second problem will be solved in the next video. In the first problem, we are being taught that the particle has a mass of 0.5 kg and it is confined to move along the smooth horizontal slot. And due to the rotation of the arm or end, we have been asked to determine the force, the force of the rod on the particle and the normal force. And the rod has a constant angular velocity of 2 rads per second, and we are assuming that the particle contacts only one side of the slot at any instant. Okay, so let's draw the free body diagram. We are using polar coordinates, so we have the radio in that direction, that's our positive, and we do have the theta direction, okay, like so, because this is moving in this direction, in the clockwise direction according to the angular velocity there. So let's label this. This is r and this is theta, and then we do have the weight. The weight again, we are assuming that the system is in the vertical plane. Okay, so we have the weight like so. We do have the weight, so that is the weight. Let me just label it like so. All right, and then we have the normal force like so, right? And then we do have the force like so. This is the force from the rod on this particular particle. Right, so with this information we can write the components. So we do have here, this is theta, and this is the normal force, and this is the weight, and this is the force. Right, so if that is theta, then we also agree that this one here is theta, right? So we do have components. We're going to have components of the weight like so, and another one like so. Okay, and then we do have components of the normal force like so, and another one like so. Right, so let's label this. So this becomes n sine theta, and this is n, I take it that this is n cos theta. Then this one is w cos theta, this one is w sine theta. Right, what else? Then we do have the direction of the motion or the kinetic diagrams. This is a theta and this one is a r. So we are on case 1, which is 13-105. So this is the case we are dealing with. So to start with, Let's also define let's define error. So that's our error like so, and that one there is our height. This one here is the angle. This is error. This is 0.5. So cos theta is just equal to adjacent 0.5. Remember this, divided by error, and error is just equal to 0.5 divided by cos theta. So we have error, which is just equal to 0.5 divided by cos theta. Therefore, the derivative of error with respect to time can factor out 0.5. We use the quotient rule. We have a 0 minus theta dot minus sine theta. Remember this, and divided by cos squared theta. Therefore, error dot is just equal to 0.5 theta dot sine theta divided by cos squared theta. So this is error dot. Let's now find error double dot. Error double dot, mind you, we have three functions: theta dot, sine theta, and cos theta squared. So I'll need to use the product rule 3 times, right? Find the derivative of one keeping the rest constant, and I continue in that manner. So we do have 0.5 derivative of theta dot, theta double dot, then I keep the rest constant. Okay, and I say plus derivative of sine theta is just sine like so, then cos theta divided by cos squared theta, then plus I make this constant, open brackets like so, and I'll have 0 minus, then I'll say 2 cos theta, okay, then theta squared, okay, right, theta squared, then sine minus sine theta. Remember this, then this divided by cos to the power 4 squared, like so. Then error double dot, this is just going to be equal to 0.5 divided by cos theta. Okay, then there we'll have tan theta double dot tan theta, theta double dot tan theta, okay, then plus theta dot squared, okay, and then plus remove this a little bit this side like so, then plus 2 theta dot squared tan theta squared like so. Okay. I think this is about it. Okay, this is about it. Then we know that. Let me just create a boundary there. I create a boundary like so. Right, so being told that theta is equal to 30 degrees and our theta dot is just equal to 2 rads and it's constant. And because it's constant, we expect theta double dot to just be equal to 0. So let's find these values. Error at 30 degrees. Alright, what do we have? That's 0.5 by 2. There we go. Alright. My other 0.5 divided by cos theta. That's 0.5774. Then R dot theta equal to 30 degrees. That's 0.5 by 2. Okay, like so. Alright, so this gives us 0.0667 at 30 equal to 30 degrees. This part is a 0. Cos theta double dot is a 0. Then what do we have? We have 2 squared plus 2 by 2 to the power 4. And then we do have tan 30 squared and by 0.5 divided by cos 30. So this gives us a 3.8490. So we have calculated all the values that we need. We need these values so that we calculate the acceleration, right? Right, so we do have our AR, which is as equal to R double dot minus R theta dot, and this is equal to 3.8490 minus R, which is 0.5774 squared. Therefore, our AR is just going to be equal to 0.8490 minus 0.5774 squared. This will get a 1.5394. We do have A theta, which is R theta double dot, plus 2 R dot, like so. Of course, this part goes to 0, right? That part goes to 0 because theta dot is 0. And then we only have 2 R dot, which is 0.6667, right, by 2. Therefore, A theta is just 2 by 2 by 0.6667, like so, which is just a 2.6668. And then we have summation of forces in the R equal to MAR. In this direction, we do have N cos theta minus W cos theta equal to MAR. So N cos 30, theta is 30, minus 0.5 by 9.81 cos theta. This is just 0.5 by AR, which is 1.5394. Therefore, our AN is just equal to 0.5 by 1.5394 plus 0.5 by 9.81 cos 30 divided by cos 30. And this gives us a 5.7938. Let me check it once more again. Okay. It's 5.7938. Then we have summation of forces in the theta direction equal to MA theta. We do have W sine theta plus F minus N sine theta is equal to M theta. Our W is just 0.5. This is 0.5 by 9.81 sine 30 plus F minus 5.7938 sine theta, which is a 30. This is a 30, and this is equal to 0.5 by 8 theta, which is a 2.6668. Therefore, our F is just going to be equal to 0.5 by 2.6668 plus 5.7938 by 0.5 minus 0.5 by 9.81 by 0.5. In this we get a 1.7778. Okay, 78. Therefore, we have our n equal to 5.8 5.79 newtons, and we do have F equal to 1.78 newtons. Normal force is going up, and the force, applied force, is going this direction like so. So I think this is about it. Let's just outline the final solutions. So we found the normal force is 5.79 and the applied force is 1.78. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.